Bismillahirrahmanirrahim. Thank you so much, Mrs. Chairman. Ladies and gentlemen, dear chairpersons. My topic today will be diabetic lung injury. How is the relation between diabetes and lung, and how diabetes is affecting the lung. This is my particular presentation, introduction, morphological changes in the lung, pulmonary dysfunction in the lung, pathogenesis, and lastly, the early learning points. Increasing evidence revealed that lung is one of the target organs for diabetic microangiopathy in patients with either type 1 or type 2 diabetes. Because the lung microvascular system has huge reserve function, diabetic lung damage is quite subclinical and often ignored by patients and physicians. This paper was talking about the diabetic lung, a new target organ. It was on 2012, and the conclusion of that paper was intensifying research into the lung as a possible target organ. Diabetes is highly addressed. Another paper was talking about diabetic lung, a sweet kiss of impending death, showing how the diabetes is affecting badly the lung vasculature in the lung parenchyma. The morphological changes include widely increase in the volume proportion of alveolar wall, thickened basal membrane, collapse of the structures of lung tissue, neutrophil infiltration, and alveolar wall thickening. The mechanism of such catastrophic events include activation of reduced NAD oxidase, activation of the polyol pathway, and we'll know how it is occurred, and generation of advanced glycation in products. What about the pulmonary dysfunction occurring due to diabetes? This paper read this topic, the pulmonary function tests in type 2 diabetes mellitus and their association with glycemic control and duration of the disease. And the conclusion of that paper was diabetes mellitus being a systemic disease affects the lungs, causing restrictive type of ventilatory changes. When we are talking about the pulmonary function tests, we have two types of restriction, either obstructive pattern or restrictive pattern. Obstructive pattern, this is restricted to the bronchial tree and restricted to the parenchyma of the lung. In diabetes, it affecting this type, this restrictive pattern, because of glycosylation of connective tissues, reduced pulmonary elastic recoil, and the inflammatory changes in the lungs. Pulmonary dysfunction in diabetic lung injury include the following: lung ventilatory dysfunction, pulmonary diffusion capacity for carbon monoxide, the lung volumes, bronchomotor tone and control of ventilation, respiratory muscle function testing, cardiopulmonary exercise test. That's to say, diabetes is affecting the whole dynamics of the lung regarding the parenchyma, regarding the function of the lung per se, as we'll show now. This lung ventilatory dysfunction, and the down graph is what's called spirometry. We are doing to assess the pulmonary function of the patient. This is a mandatory. We are starting first before issuing any prescription to know what is the baseline of this patient. If this patient belongs to what's called obstructive type pattern, like asthma, like COPD, like bronchiectasis, or restrictive pattern of pulmonary function, that's, for example, diabetes. Diabetic patient exhibit a restrictive impairment of lung function, and you can see from the graph, the up one is the normal and down one is the restrictive pattern. This paper was talking about the high prevalence of restrictive lung disease in people with type 2 diabetes, and this opened the gate for us to assess the pulmonary function before rushing in prescribing anti-diabetic drugs. Lung ventilatory dysfunction, the early stage of diabetes, modulates the bronchial reactivity to both acetylcholine and isoproterenol by disrupting the nitric oxide, potassium ATP channel, and the cyclooxygenase pathway in GNP. The hypothesis of that was there have been several hypotheses, like decreased respiratory muscle strength because of the peripheral neuritis, because of the easy fatigability in uncontrolled diabetic patient, the restrictive type of pulmonary impairment, as I said, abnormal ventilatory response to hypoxia, hypercapnia, or exercise, and decreased the non-adrenergic, non-cholinergic neurotransmitter release. What about the pulmonary diffusion capacity? We mean by diffusion, that's the transmission of gases, that's oxygen and the carbon dioxide, across what's called alveolo-capillary membrane. This diffusion is influenced by alveolar capillary membrane conductance and pulmonary capillary blood volume, both of which are reduced in adults with type 2 diabetes. And as you can see here down, this is the alveolus and this is the capillary, and we can see how the gas exchange is occurring. Oxygen is coming from the alveolus to the blood, to oxygenate the blood. In the reverse direction, carbon dioxide is released from the blood to the alveolus and to the outside. This paper was published in the Egyptian Journal of Chest Disease and Tuberculosis about the pulmonary function changes in diabetic patient. The conclusion was that the present study showed significant, again, restrictive ventilatory dysfunction in uncontrolled diabetic patient with myocardiopathy as compared to controlled patients. What about the lung volumes? The third National Health and Nutrition Examination Survey, that's NANES 3, 2005, found that previously diagnosed diabetes patient had lower FEV1 than non-diabetes. What's meant by FEV1? That's forced expiratory volume in 1 second. We are giving the patient what's called peak flow meter, very small apparatus, very cheap, and we advise always the patient to have this to monitor and judge and to control himself to know how his pulmonary function of him is going badly or going in a proper way. We are asking the patient to have deep inspiration like and forced expiration in 1 second, and then we are measuring and calculating the number reading. This shows how the pulmonary function is going in a good way or in bad way. The Framingham Offspring cohort and the Heart and Health study reported also a reduced FEV1 in diabetic patient, and that one you can see what's called the peak flow meter, very cheap. This paper was published in American Journal of Respiratory and Critical Care Medicine, and the conclusion was talking about the association between glycemic state and lung function, the Framingham Heart study, and got the conclusion of both the diagnosis of diabetes and the higher level of fasting blood glucose were associated with lower than predicted level of pulmonary function. In a cross-sectional analysis, the atherosclerosis risk in communities that ARIC study has reported again that the values of FEV1 and FEVC, that's called forced vital capacity, were significantly lower in type 2 diabetes than in healthy control. And in addition, parenchymal damages to lung of diabetes patient has also been reported. This paper was a very nice paper. It was talking about the breathlessness and restrictive lung disease, an important diabetes-related feature in patients with type 2 diabetes, and had the conclusion of that. This study demonstrated increased breathlessness and the high prevalence of restrictive lung disease in patients with type 2 diabetes, indicating an association between diabetes and fibrosing interstitial disease. ILD means interstitial lung disease. This is a very hot subject, needs a separate lecture, and the patient with that disease living a very miserable life. They have progressive dyspnea until death. This paper was published in Lung, India, about the pulmonary function patient with diabetes mellitus. You can see how this subject is very hot, and it took the attention of all literatures from all over the world, and got the conclusion that diabetic patient should impaired lung function, independent of smoking. So now the issue is not to rush into prescribing a very expensive anti-diabetic drugs. You have first to stabilize the lung condition. You have to know what is the baseline of your patient before prescribing the medication, and then after controlling all these comorbidity, you can start prescribing the medication. And this reduced lung function is likely to be a chronic complication of diabetes mellitus. What about bronchomotor tone and the control of ventilation? Diabetic patient with autonomic neuropathy showed an increased lung uptake of 1 to 3 MIBG, that's called beta-isobenzoyl and a decreased rate of its clearance. In particular, Bertherac et al. Have reported about a reduced bronchorestrictor response induced by methacholine. The reduction of the parasympathetic bronchomotor tone may cause an increase in airway caliber at baseline. As you know, we have sympathetic and parasympathetic. Sympathetic is causing bronchodilation and parasympathetic causes bronchoconstriction. The sympathetic component seems to play an important role in modulating the response of the respiratory center to hypercapnic stimulation. What about respiratory muscle function testing? Ultimately, if the pulmonary function is reduced, definitely the respiratory muscle strength will be very weak. So the patient cannot take a deep inspiration, and the net result will be increased hypercapnia, that's called increased carbon dioxide tension in the blood, and reduced oxygen, that is hypoxia. The level of respiratory muscle strength have been found to be generally low, mainly in patients with type 1 diabetes. So this is the problem, that diabetes in both types, either type 1 or type 2, affecting the lung function. And the recent study with type 2 diabetic patient showed a modest reduction in respiratory muscle strength. And this paper was talking about the impact of diabetes on functional exercise. We have what's called 6-minute walk test. We're asking the patient to walk for 6 minutes, and then we assess the pulmonary function, whether the patient will go dyspneic, distressed, or he can continue this walking. And pulmonary function patient with diabetes and healthy persons. And the conclusion of that paper was the 6-minute walk test is a valuable test that complements the assessment of daily physical capacity in patients with diabetes, irrespective of time. Various authors have demonstrated that during the incremental increase test, type 1 diabetic patient have a peak of oxygen uptake. The main factor reducing this in type 1 diabetic patients seem to be glycemic control. So we have to control the blood sugar first before issuing any medication. Poor glycemic control seem to have a stronger detrimental effect on chronotropic heart response. This illustrates or summarizes what is happening in the pulmonary function in diabetic patient. We have reduction in all these parameters: lung volume, diffusion capacity to carbon monoxide, gas exchange, bronchomotor tone, ventilatory response to hypoxia, and response to hypercapnia. What about pathologies? Pathologies of diabetic lung injury. How diabetes will affect the lung and causing lung injury? We have diabetic hyperglycemia, as you see, and all these pathogens will occur. That's glycation, that's the protein kinase C pathway, nuclear factor pathway, polyol pathway, and oxidative stress, and all these co-conglomerate and compete all together to have one target, that's diabetic lung injury. And we'll see everyone. Oxidative stress, sustained hyperglycemia producing exercise reactive oxygen species that trough and reactive nitrogen species trans, resulting in damage to DNA, lipids, and proteins. Evidence indicates that in diabetic lung, the activity of superoxide dismutase was decreased while the contents of nitric oxide and malonyl-dialdehyde, MDA, were significantly increased. So the oxidant will increase, and the antioxidant, that is a physiological mechanism present in the human body by blessing of God, will be decreased. Clinical data illustrates that tumor necrosis factor, alpha, interleukin, the mediator, interleukin 6, 10, and the mediator level in serum were all significantly increased in diabetic patient. We know that there is a sequence of events of inflammation and oxidative stress affecting the lung function, and tissues exposed to continuous state of high blood glucose can exhibit non-enzymatic glycosylation of proteins. In the course of collagen accumulation in the lung, the increased stiffness of both lung parenchyma and chest wall could explain the restrictive functional effect appearing in lung disease. This cartoon will show how is the hyperglycemia affecting the lung function. You see here the increase in polyol pathway. This will affect in the antioxidant mechanism, will decrease it, and this will lead to oxidative stress. The same way, polyol pathway also will lead to oxidative stress. Increased glucose oxidation will cause oxidative stress and will cause advanced and increased glycosylation in the protein. And this with glucose auto-oxidation will lead to oxidative stress. And oxygen risk ultimately will be increased by increase in the concentration of reactive oxygen species. Polyol pathway is one of the major sources of ROS production in diabetes. The hyperglycemia decrease NAD level by activation of the polyol pathway and by overactivation of polymerase PRPE. And additionally, damaged mitochondria can also generate an excess of superoxide that can mediate tissue injury in diabetes. What about the role of mitochondrial dysfunction in diabetic lung injury? Actually, this term, that's mitochondrial dysfunction, now took a great attention all over the world. And I was just talking with the chairperson about 1 month ago. I was in Barcelona, Spain. They were talking about the mitochondrial dysfunction and how this now interfere in all specialty, not only in diabetes, not only in lung, but also in other diseases, like for example, in psychiatric problem, dementia, Alzheimer's disease, cardiovascular disease, etc. So mitochondria can be both a source of ROS and a target of oxidative damage during oxidative stress. Prolonged hyperglycemia, this is an overgeneration of ROS by the mitochondria. So mitochondria per se generate ROS, and presence of hyperglycemia exaggerate this response also. The role of mitochondria, again, it has been reported in the base that C-peptide induces AMPK activation and inhibits hyperglycemia-induced ROS, mitochondrial membrane potential collapse, mitochondrial fission, and endothelial cell apoptosis. Moreover, hyperglycemia-induced overproduction of mitochondrial ROS may lead to collapse of mitochondrial transmembrane potential and the opening of the mitochondrial permeability transition wall. And this shows this illustration. This is the mitochondria and how the membrane will be penetrated, leading to release of the ROS through this MBTP opening, and this through a various series of cascade. Very dangerous cascade will lead to apoptosis, and this will lead to lung injury. What about nuclear factor kappa B pathway? The nuclear factor signaling pathway is involved in regulating gene expression in early inflammatory response and is a primary target for activation by hyperglycemia. Nuclear factor has been shown to activate the genes encoding pro-inflammatory cytokines as well. This paper was talking about the potential biochemical mechanisms of lung injury in diabetes, and got the conclusion that further understanding of mitochondrial mechanisms of diabetic lung injury should provide invaluable insights into future therapeutic approach for diabetic lung injury. Now they are talking about what's called mitochondrial transfer. They are transferring the mitochondria to patients with diabetes, and this is now the new era all over the world. Protein kinase C pathway is a family of enzymes that are involved in regulating the function of numerous proteins. It has been associated with vascular alteration, such as increase in permeability contractility, extracellular matrix synthesis, cell growth and apoptosis, angiogenesis, leukocyte adhesion, and cytokine activation and inhibition. This paper was talking recently about this problem that diabetes and lung disease, a neglected relationship. Still, everyone in Egypt, in his or in her specialty, treating patient from her own view only. We have to take the human body as one unit. And the conclusion was the lung is one of the most neglected target organs of diabetes. Thus, the Diabetes Lung Association is considered a newly investigated concept. Diabetes should be considered as a relevant factor in the clinical approach to lung disease patient. Last year, I was talking here about the infection in the lung caused by diabetes, and I was talking about tuberculosis. And from this point, we have to start evolving this issue that we have to screen diabetic patient for lung disease and vice versa. So we can get our conclusion from this presentation that lung is a target organ of diabetes. We have to put in your mind that your patient, is a diabetic patient, whether insulin dependent or oral dependent, may be having a great problem in his lung. So you have to screen by doing two things. You have to screen by chest X-ray even if the patient is complaining, and you have to screen also by doing pulmonary function test. Inshallah, if there is still life, next year I will talk about diabetes and lung cancer. The consequence of abnormal lung function in patients with diabetes are clinically relevant. Several histopathological features of the lung seem to be related to diabetes. Abnormal regulation of bronchomotor tone and neuroadrenergic dysfunction is widespread in patients with autonomic diabetes-related neuropathy. Oxidative stress has been postulated to be a major contributing factor in diabetic lung injury, not only in diabetes but also in all specialties, in all diseases. Periodic monitoring, as I said, of the respiratory function in patients with diabetes is an appropriate action. So as you are prescribing and you are advising the patient to have fasting blood sugar, you are advising to have postprandial, you have to advise also hemoglobin A1C, estimate glomerular filtration rate. Please do two things. Very simple chest X-ray will reveal what is the lung structure and the function of this patient, and do also pulmonary function test. Thank you so much for your attention.